Hi, and welcome to my video on extra problems on a circle, part 1. What I've done is made up some extra problems to use the math that we've learned in this unit plus math that's in other units. So let's have a look at some of the questions. A square ABCD is inscribed in a circle such that A is 2, 1, B is 2, 5, C is 6, 5, D is 6, 1. Find the equation of the circle in standard form. So we have a square and we want to find the equation of the circle. So the equation of a circle, we need a center and a radius. So I got a grid drawn here, and I always draw a grid to help me explain or see what's going on. The square A is 2, 1. A, x is 2, y is 1. So that's A. B is 2, 5. B is x is 2, y is 5. 2, 4, 5. So we can see. So that's B. C is 6, 5. X is 6, 1, 8, 5, 6 here, and out 5. We're drawing a square. So there's C. And D is 6, 1. 6, 1 right here. So what we have is a square. And all sides of a square, this is D here, all sides of a square are equal. But it says that a square is inscribed in a circle. So that means there's a circle passing through A, B, C, D. So that means if the circle is passing like this, so let's draw a circle. That means that the center of the circle must be in here. So the center of the circle, let's say it's right there, just approximately. That means that we want to find the center of the circle, and then we get the radius. So in relation to a square, if we draw the diagonals of a square, AC and BD, then the two diagonals are congruent and the diagonals bisect each other. So let's draw the diagonal AC, BD, and label this point as O. So if we can get the coordinates of O, which because they bisect each other, O is going to be a midpoint, then O would be the center of the circle. And then if we get the distance from the center, O, to A, we'll get the radius, and that will give us the equation. So here we go. Let's say that O is the midpoint of AC. So let's find the midpoint of AC. So the midpoint is, we add up the x's and divide by 2, and we add up the y's and we divide by 2. So we have AC, the midpoint of A is 2, 1, and C is 6, 5. So we sub them in. This is x1, y1, x2, y2. So we add them 2 plus 6 over 2, x1 plus x2, y1 plus y2, 1 plus 5 over 2, and 8 divided by 2 is 4, and 6 divided by 2 is 3. So the center of the circle, which is I'm labeling as O, O is 4, 3. Now, if we take A, which is the point on the circle, so we take A to be 2, 1, that means that AO is the radius. So if we call this one x1, y1, x2, y2, then the radius, which is AO, is y2 minus y1 squared, x2 minus x1 squared, and sub all those numbers in. Y2 is 1, y1 is 3 squared, x2 is 2, x1 is 4 squared. So 1 minus 3, 2 minus 4. And 1 minus 3 is negative 2 being squared. This is negative 2 being squared. So that's a 4 plus 4. Negative 2 squared is 4. And negative 2 squared is 4. That's the square root of 8. And 8 is, square root of 8 is 4 times 2. So it's 2 root 2. So we have a circle. We have a center, which is 4, 3. So the equation is x minus h all squared, y minus k all squared equals r squared. And so we have a 4, 3. So it's x minus 4 all squared. Y coordinate is 3, so we change the sign. And the radius is 2 root 2 squared. So the final form is same here, and 2 root 2 times 2 root 2 is 2 times 2 is 4. Root 2 times root 2 is root 4, which is 2, so that's an 8. So there's the equation that represents the square. Notice the square is inscribed in the circle, so all points on the circle, all points that are made up the coordinates of the square lie on the circle. So the square is touching the circle. All vertices of the square are touching the circle. Okay, there's one problem. Let's have a look at another one. Don't forget, you can pause the video at any time. Now, the equation of a circle is x squared plus y squared minus 4x plus 2y minus 20 equals 0. Find point P, from point P, two tangents intersect the circle at 5, 3, which is A, and B, which is 5, negative 5. Find the coordinates of P. So, there's 2 points that lie on a circle. So what we need is, we have a circle, and we need to find the center of the circle. And then, once we get the center of the circle and we get the radius of the circle, then we're able to draw the circle, and we'll plot the 2 points on the circle and look and find the tangents. And the tangents, we have tangents, and a tangent is perpendicular to the radius of a circle, and perpendicular lines have negative reciprocal slopes, or the products of the slope is negative 1, the same thing. So let's take the circle equation and change it to, this is the general form, change it to standard form. So we group the x's, group the y's, and move the 20 to the right to make it positive. Half of negative 4 squared, negative. Half of negative 4 is negative 2 squared is 4. Half of 2 squared is 1, 1 squared is 1, so we're balancing it. So this is a perfect square trinomial, so a half of negative 4 is negative 2 being squared. We got a y. Half of 2 is plus 1, and we squared. So this is a perfect square trinomial, which is factorable. This is the perfect square trinomial, which is factorable as a binomial squared. So this is a 25. So we have the center of the circle is, we have 2 and negative 1. So that's the center. So we let O be the center, and r squared is equal to 25. So r is the square root of 25, which is 5. There's a plus minus there, but we'll just take the 5. So what we have is a circle which has a center of 2, x is 2, y is negative 1, and has a radius of 5. What I'm going to do now is, just to illustrate it, I'm going to draw this circle and a radius of 5. So let's take 5 to be from, there's 5. So we'll take our protractor, put it on the center, and mark off the circle, which is, and again, this is approximation. It's not always accurate when I'm dealing with the compass and that. So here we go. So there's passing through there, and always off a bit because the thickness of the pencil, and etc., etc. So there's the circle. Now, what we have, it says that from a point P, two tangents intersect a circle at A, which is 5, 3. There's x is 5 and y is 3. There it is right there. So this is A, which is 5, 3. And is also intersect at 5, negative 5. So negative 5 is here, so take an approximation. So there's B to be 5, negative 5. So what we have is the tangents are intersecting the circle at one point. So if we mark off the radius like that, and we mark off this radius going to B, and this is O is the center of 2, negative 1. So what we have is a tangent that intersects the circle, and it intersects at a right angle. So what we have is, if you can just draw this one, they're going to be perpendicular. So there's a tangent coming through here like this. And it's going to be perpendicular. So let me extend that, but to be approximate, not going to be exact, but I'm just drawing a little picture. So there's one tangent coming perpendicular, and now we have another one, and they're going to intersect at a point. So this one is coming over here, and again, it's an approximation. So the point is somewhere over here. So there's the perpendicular there, there's the perpendicular there, here's the tangent, one tangent intersecting at a right angle, here's another tangent intersecting at a right angle. Now we need to find this point P. So that's approximation, but the algebra will work out to be okay. So let's take this point, let's take this tangent PA. Let's take the tangent and PA. So PA is the tangent. So what we need to do is get the slope of the tangent is the negative reciprocal of the slope of this radius. So let's get the slope of AO. And again, O is the center of 2, negative 1, and A is 5, 3. So the slope of this radius is y2 minus y1, so that's 3, subtract negative 1, all over 5, subtract 2. So that gives us, that's 3 plus 1, which is 4 all over 3. So the slope of the tangent is the slope of the tangent, or the perpendicular line, is the negative reciprocal. So we turn it over, 3 over 4, and we make it negative. And also, Now, what we have the slope of this tangent. So we need to find the equation. So y equals mx plus b. And we have the slope of the tangent, and we have a point A. So A is the point of 5, 3. So this is x and y, and that's m as the slope. So that's a 3. X, the slope is negative 3/4. X is 5, and we work out what b is. So 3 equals, that's negative 15/4 plus b. So b is equal to 3 plus 15/4. So b is equal to, that's 12/4 plus 15/4. So b is 27/4. So that means the equation is y equals, slope is negative 3/4 x plus b, which is negative 27/4. So we found the equation of the tangent. That's AO. Now, let's find the slope of the tangent. Let's work out the tangent of BP. So BP, the slope of that tangent, we'll work on the point, which is 2, -1, and we'll work at 5, -5. So this tangent is coming through. There's O, and there's B. So we'll get the slope of OB. And the slope of OB is -5, subtract -1, y2 minus y1 over x2 minus x1. So that's double negative is a positive. Again, back here, double negative is a positive. So it gives me a 4. That's -5 plus 1. That's -4. 5 minus 2 is 3. So the slope of the tangent, which is BP, is going to be negative. So that's a negative. We change the sign, which is positive, and we make it 3/4. Now, same as this one, and I'm putting them parallel to each other, side by side. So the point that we have, this tangent is going through B. So B is 5, -5. So y, that's x and that's y. So this is the point that's on this tangent B, and we know the slope is the negative reciprocal of this one, which is 3/4. So we'll put -5 equals, m is 3/4, x is 5. So you can see this is a good question. So 3/4 times 5/1 is 15/4. So b is -5 minus 15/4, -20/4 minus 15/4, common denominators. So b comes out to be -35/4. So the equation, y equals the slope, is 3/4. And the y-intercept is -35/4. So we have the slope of these two tangents. Or sorry, we have the equation of these two tangents. So if we solve these two equations, we'll get this point P. So let's solve the equations. So -3/4x plus 27/4 equals 3/4 x minus 35/4. So if we notice they're all common denominators of 4, so if we multiply every term by 4, multiply all terms by 4, 4 times -3x/4, 4's cancel, we get -3x. 4 times 27/4, we get 27. 4 times 3/4 x is 3x. 4 times negative 35 over 4 is negative 35. Notice the 4's cancel out. Now we have negative 3x minus 3x equals negative 35 minus 27. Negative 6x equals negative, and that's 62 divided by negative 6, and we get x equals 31 over 3. Negative over negative positive to reduce. Now we have x is negative 31 over 3. So we sub that negative 31 over 3 into, let's sub it into this equation here. Let's go y equals 3/4. X is negative 31 over 3 minus 35 over 4. The 3's cancel out, and I get 31 over 4 minus 35 over 4. Common denominator is 4. 31 subtract 35 is negative 4. That gives us negative 1. So point P has x coordinates of 31 over 3, and the y coordinate is negative 1. And this is an approximation. So doing it, when you do geometry of it, you get an approximation. When you do the algebra, you get the actual values of the x and y coordinates. So notice, excellent problem pertaining to tangents having negative reciprocal slopes and equations. Beautiful problem that sums up a lot of equation of a line, slopes. Perfect. Beautiful question. And if you like my video, click on the like button and click on the subscribe button if you're not a subscriber. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content of my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video was of some help to you. Bye-bye.